Hello everyone, we are very honored to present at MediaEval 2018. Thank you so much for having us.
Hi, I'm Chloe, and I'm a senior at Punahou High School in Hawaii.
And I'm Julia, an undergraduate first year at MIT.
To continuously predict which segments in movies are fear-inducing, we decided to work with variations of LSTM models. Our main models include a singular LSTM network and an ensemble of LSTMs. We also experimented with the inputs to the LSTM models by using different feature extractors. For example, we used different combinations of audio and visual features in some of our tests.
For deciding our architecture, long short-term memory networks seem to be a strong candidate because of their strong abilities to model time series data. This especially seemed appropriate for the fear prediction task, since the content of each scene in a movie is correlated with the content of previous scenes. Additionally, LSTM models trained on AlexNet and Google LeanNet had outputs that performed very well for video action classification.
In our approach, we experimented with different combinations of feature extractors and architectures. We used FC6 visual features, the outputs of a pre-trained VGG16 model, that were provided by the lyricicide dataset. These FC6 features were extracted with the MATLAB Neural Networks toolbox. We also used audio features provided by MediaEval, which were based on low-level descriptors and extracted with the OpenSmile toolbox. The FC6 feature data and audio feature data were compiled into separate matrices and padded, such that the max number of time steps for each movie was 6,262 seconds. We chose a window size of 101 seconds to slide over the time step axis, with no seconds of overlap. Each window of feature data was fed into our LSTM model. For the first 3 runs, we used an ensemble of LSTMs. 3 of the LSTMs in each ensemble were single-layer LSTMs with batch normalization. The fourth LSTM model in each ensemble was an LSTM with a 1D temporal convolutional layer attached. Each LSTM in the ensembles was trained on a different subset of the training data, and the outputs of all the models in each ensemble were joined with a simple average function. For the other 2 runs, we used a single LSTM layer with either visual or audio feature inputs. Outputs of all of our models were one-hot vectors. 1s corresponded to fear-inducing seconds, and 0s corresponded to non-fear-inducing seconds.
In analyzing our results and conclusions, it seems that the single models performed significantly better than the ensembles. This could be in part due to the fact that ensembles were joined with only a simple average function. Scores may have improved if the models with better performance were given more influence with a weighted average function. Of the 2 single-layer LSTMs, the one trained on FC6 data showed much better results, which may mean visual features are more relevant to predicting fear-inducing seconds.
There are multiple ways to improve on the models suggested here. The following are several avenues of future research that interest us. First of all, we chose 101 seconds as our sliding window length, but a shorter window size and more overlap while training the LSTMs may make it easier for the LSTM models to remember patterns in the data. Also, a shorter window size with more overlap could make it easier to handpick a more balanced set of training data. As briefly mentioned before, using a different concatenation function may improve the scores of the ensemble models. So, for example, using a weighted average function instead of a simple average function. Designing a cost function that penalizes the LSTM more heavily for predicting 0s when it should be predicting 1s could be another way to overcome the heavy bias in the training data. Also, AlexNet and Google LeanNet outputs have been used with notable success in LSTM models for video action classification, which seems like a task that is related to fear prediction in movies. Finally, 2 relatively new cutting-edge models that have been proposed for analyzing video data are first of all, the DeepMind's i3D model, which has achieved state-of-the-art results for video action classification. This could be interesting to look into for fear prediction as well. And also there's a phased LSTM, which has improved the LSTM's ability to predict infrequent events in time series data, which could be applicable to fear prediction in movies. In any event, these are interesting future avenues to consider, and we want to thank you a lot for taking the time to listen to our presentation today. Thank you very much.